Imagine you're applying for a scholarship that only goes to the top 10% of students, or the 90th percentile. Your last exam score came back and you found out that you got a score of 85%. You know that the average grade was 68% with a standard deviation of 10. How are you supposed to find out if you've reached the cutoff and maintained your scholarship eligibility? To answer this, we need to use one of the most important distributions in all of statistics, the normal distribution. This is because exam scores are actually approximated by a normal distribution. Other things that are approximately normally distributed are weight, blood pressure, measurement errors in manufacturing, and even job satisfaction. Because of the breadth of data explained by this curve, it is extremely important to understand. The normal distribution is a bell shaped curve where the height represents the likelihood of obtaining that value. It is centered at the mean, and since the distribution is symmetric, the mean also represents the median with no skew present in the curve. Another property is the 68, 95, 99.7 rule, which states that 68% of all the data is within one standard deviation of the mean, 95 within 2, and 99.7 within 3. For a deeper dive into why the standard deviation is so useful, check out my other video linked in the description. Behind the normal distribution is this complicated equation, but don't worry, even though this equation seems complex, you'll almost never need to use this directly, and it really just says that extreme data points get exponentially rarer from the mean. The standard normal distribution is a simpler form of this and commonly used when the mean equals 0 and the standard deviation is 1. And this is commonly used because we have a table from the standard normal distribution to compute probabilities by looking at the z-score. The z-score is usually what is used instead of the formula, and it is much simpler to calculate. If we don't have the standard normal distribution, such as in our problem above, we can still find out our exam score and the probability of obtaining it with z-scores. To find the z-score of a non-standard normal distribution, we take our data point, minus the mean, and then divide by the standard deviation. This standardizes it, or makes it so we can use a table of values to calculate probabilities and percentiles for non-standard normal distributions. Now with this, we can actually find our percentile. The z-score would be 85 minus 68 divided by 10, which gives us a value of 1.70. We then can use a standard normal distribution table because we standardized our data to look at what this value is. These tables might seem complicated at first, but they're pretty easy to read. You look on the left-hand side first to find the first two numbers, like 1.7, and then look at the top for the last decimal point, in this case 0. And then that number is our probability. We can then find the probability of this value to be p, the probability of z less than or equal to 1.7, and the value is 0.9554 from the table, or 96% rounded up. This means a score of 85% is greater than 96% of all of the data and shows we are in the 96th percentile and reach the cutoff for a scholarship. But how about if we knew the percentile but not the exam score? Well, we could always invert the process. Let's say we want to find the minimum exam score needed to be in the top 10% of the class. We could then look at that table from the standard normal distribution to find when that cumulative probability would be equal to 90%. It appears in our case that it's between 1.28 and 1.29. So we can just take the middle of the two values. So when the probability that z is less than 1.285, we have a z-score of 0.9005, which is close enough. Now we can work backwards from the z-score formula to get 1.285 times 10 plus 68, which equals 80.85, or 81% rounded up. So we were then 4% off from not reaching the cutoff, since the minimum exam score needed to maintain eligibility was only 81%. Now try this yourself. What score would you need to land in the 99th percentile? Leave your answers in the comments down below, and like, comment, and subscribe if this helped.